This is Group Stud Muffins, and we will be covering Chapter 3, Section 3. Section 3 covers intermolecular forces between molecules and their effects on boiling and melting points. Alright, there are three main types of intermolecular forces. Starting with the weakest, we have van der Waals, and then dipole-dipole, and the strongest of the three we'll be talking about is hydrogen bonding, or H bonding. The first of the three intermolecular forces is named after the Dutch scientist Johannes Diederik van der Waals. Van der Waals forces are the weakest of the three forces. They exist in all molecules. The strength of the van der Waals depends on the size of the molecule, so a larger surface area means a larger attraction force. Van der Waals forces affect both melting point and boiling point. And just for the record, boiling point is a change from liquid to gas, and melting point represents a change from a solid to a liquid. An example of how this works can be seen with pentane. Its boiling point is 36 degrees Celsius, while its melting point is negative 130 degrees Celsius. Later on, you will see how the melting point and boiling point changes with other forces.
Dipole-dipole interactions. What are they? An attraction between two polar molecules with one having a partial positive and the other having a partial negative end. An example of this intermolecular force is between two HCl molecules that have two partial charges on each end. The Cl has a partial negative charge while the H has a partial positive charge. The partial positive charge on one of the hydrogens is attracted to the partial negative charge on the chlorine, causing a dipole-dipole interaction. More examples of this dipole-dipole interaction are drawn in blue. These are examples of dipole-dipole interaction because of the electronegatively charged oxygen that causes these molecules to be polar. Dipole-dipole interactions between two H2O molecules causes hydrogen bonding. This is because water is polar just as the HCl was. However, the bonds between these water molecules is much stronger, and because the hydrogen is bonded to an oxygen, this causes hydrogen bonding.
Finally, we arrive at the strongest of the three intermolecular forces, hydrogen bonding. As it is labeled, hydrogen bonding is actually a bit of a misnomer, as it implies a connection between two molecules such as an ionic or covalent bond. However, it is merely an attractive force. Hydrogen bonding typically occurs when a hydrogen atom bonded to fluorine, oxygen, or nitrogen is electrostatically attracted to the lone pair of electrons on another oxygen, nitrogen, or fluorine atom from a different molecule. Both boiling point and melting point are increased as a result of the existence of hydrogen bonds. This is because molecules are attracted to each other, and the boiling point is raised because it is less likely to separate and become a gas. Also, it is less likely to separate from its solid phase and transform into its liquid. One example to show the effect that hydrogen bonding has on a molecule's boiling point is the comparison between acetone and water. Acetone has a boiling point of 56 degrees Celsius, and water has a boiling point of 100 degrees Celsius. This is as a result of the hydrogen bonding present in the H2O molecule, providing stronger intermolecular forces which make them less likely to separate than the atoms within the acetone molecule, which only exhibit dipole-dipole interactions. As previously mentioned, dipole-dipole interactions create higher boiling points than just the VDW forces, as is evidenced by acetone's 56 degree boiling point. However, hydrogen bonding is still the most powerful. The simple addition of the two hydrogens to the water molecules nearly doubles the boiling point.
Effects on boiling and melting point. The more intermolecular forces result in a higher boiling point because the forces are harder to break. This is also the same for melting points. The first molecule only has one intermolecular force, which causes it to have the lowest boiling point and melting point. The middle molecule has two intermolecular forces, which is why it has the second lowest or highest boiling point and melting point. The last one has 3 intermolecular forces, which causes it to have the highest boiling point and melting point.